a question comes in my mind. Why is an all-screen phone very difficult to manufacture? When you look at a modern smartphone, you have a very large display, but that display has some borders to it, some edges to it, and you might be seeing a very small chin of your smartphone. Wouldn't it be great to have an all-screen phone where the complete cell phone is a display? Our current smartphones have bezels or edges on them that are around the screen, and on the top and bottom there is sometimes a cutout, a notch and a chin area. So why is it so? Why are these borders present? The screen of your smartphone is made up of tiny pixels, and these pixels are arranged in a grid-like pattern. Each pixel can be thought of as a unit of display, means it can generate its own color. In every pixel we can see that there are 3 subpixels, and these 3 subpixels are of the color red, green and blue, which are the primary colors that when combined together gives us white. And the combination of these primary colors gives us the other millions of colors we see in our displays. Subpixels combine to form a one single pixel and gives color to it. But we have to control these subpixels somehow. So in a display there are small devices that allow the subpixels to turn on or off, and with varying intensity or color brightness. This is through the small device called as a transistor, and this transistor controls the pixel and sets its color. The transistor is connected to a control circuit that is responsible for turning the subpixels or selecting them. The signal circuit contains the signal that tells the subpixel for the intensity or the brightness of its light. So if a signal is stronger, the subpixel will lit up more, whereas if the signal is less, the subpixel will be not that bright. Pixel pattern is arranged in a grid where there are wires running around. There are some vertical wires which are connecting all the pixels in a single column, whereas there are horizontal wires that are connecting all the pixels in a single row. The wires that are connecting the pixels in a row are the control circuit, whereas the wires that are running vertically and connecting all the columns is called as the signal wire. And the intersection of these wires, the control and the signal circuit, helps us select the single pixel we wish to light up and give a specific color to it. So if I apply voltage on the horizontal or the control circuit, all the pixels in that row will be selected. And now when I provide the signal to the vertical or the signal wires, the color information will be captured by that pixel and the pixel will glow in that respective color. The modern smartphone display is manufactured onto glass, but special circuits are needed to control the pixels and their transistors. And this circuit is called as a display driver chip. So there is a special chip that controls the display of the smartphone. And the problem is that this driver chip cannot be made on glass. So we have the control wires and the signal wires coming out of the pixel grid, and these have to be connected to the display driver chip. And the display driver chip is mounted on the edge of the display. So the wires running from the display are connected to it. There are thousands of wires that are coming out of the display panel. The number of wires that are coming out of the display depends on the resolution of the display. I will give you an example. Let's assume that you have a full HD resolution smartphone. The resolution of the smartphone for the full HD specification is 1920 by 1080, where 1920 pixels are arranged in a row or horizontally, whereas 1080 pixels are arranged in a single column. One pixel equals 3 subpixels, so 1920 pixels equates to 5760 subpixels. Each subpixel is controlled by a separate signal wire, whereas each row is controlled by a separate control wire. So in total we have 5760 signal wires that are running vertically along the display, whereas 1080 control wires are running horizontally along the display. And the total wires, which is the control wires plus the signal wires, amounts to 6840 wires. These are a lot of wires to pack in the small display. and we need the edges and the chin area of the display to pack such a large amount of wires, because the wires need space as they are connected to the driver chip individually. As you can see that there is a single control chip on the display which controls all the driver chips, and multiple driver chips are present on the horizontal and the vertical side of the display to directly connect to the signal wires and the control wires. The control wires are less in number and they can fit on the edge of the display. So the edges of the display are very thin, whereas the signal wires are more in number and cannot be assembled on the edges of the display, so they require the chin area or the upper area of the display to connect to the driver IC. So this is why all screen phones are not possible till now. But in future, when the technology evolves and when the chips can be made directly on glass and they can be made transparent and thin nanowires or thin wires can be used to make the circuits, then only we can see an all display phone sometime in the future. Thanks for watching my video. Do subscribe my channel if you like this content. Give a big thumbs up to the video, and also do not forget to press the bell icon